Welcome to Wits Software Development, supported by Mathematical Science. This course is designed to help introduce you to the world of software development. Throughout the course, there will be links provided for further reading on the topics we cover. This course we will be using the Mean Stack, which is a technology stack which includes Node.js, AngularJS, ExpressJS, and MongoDB. This lesson we will be covering Node.js and related concepts. Here are some interesting links. Nodeschool.io, where there's a very good collection of tutorials and interactive sessions which you can install on your computer and run. And try.github.io, which is an interactive web browser tutorial on how to use Git. This is nodeschool.io. As you can see, there's many different tutorials on many different topics using the Mean Stack and related technologies, such as JavaScript, Node.js, Git, the Node Package Manager, and many others. And here is try.github.io, where everything's interactive and it's self-explanatory on exactly what you need to do. Tools that you will need for this course is Git for Windows with Git Bash, Node.js, which includes the Node Package Manager, npm, MongoDB, which is the Mongo database, we'll be using that later, RoboMongo, which is an interface for accessing MongoDB, and any code editor. I will be using Sublime Text, but you're welcome to use any code editor you want, and npm programs, which we'll cover on how to install later on. npm, or the Node Package Manager, is the tool which is used to help install libraries and code modules from the Node package repository online. Once Node.js is installed, if you are using Windows and not Linux, you may need to change your global paths in order to access Node.js. There's a link in the slides provided to help you with that. For all my examples, I'll be using Git Bash, so anyone who's using Linux or Windows with Git Bash will be able to follow along and copy what I'm doing. There are certain programs that you will need to install with npm. This is for later sessions, not for this session. And on the slide you can see I use the command npm install -g Istanbul, Makkah, Chai, and Gulp. The -g tag helps to tell the Node Package Manager to install these tools globally and not within the folder that you're working in. Without -g, you are installing a library and not necessarily a tool. Software design is not just about programming. There's a lot more analysis, design with programming, and testing which goes into software development. There's also a lot of teamwork and a lot of methodology behind building software in a business or some kind of professional or open source environment. As I mentioned, teamwork is integral to software development. In this case, it helps improve output quality of your work. It helps building very large and complicated systems where not one person alone could do it. It also helps with efficiency in getting your work done really quickly, division of work, and the morale of the programmers working on building these software systems. There's a lot that goes into working as a team. You have to have standards and consistency in your work so that other programmers who haven't come into your domain are able to look at your code and understand what is going on. We will be covering in future sessions specific models of working and structuring your code in order to help facilitate teamwork. When building software, the first question you need to ask is, what problem are you solving? If you don't ask this question, you can have disastrous results. You can have things such as feature creep, where extra features keep being added to the program and you never have a completion point. Your program constantly needs to be updated and things need to be added, and it grows into this very vast and large system that's unmaintainable. You can also have bugs that start to be added to your project as you start cutting corners. And you can even make a program which doesn't truly solve the problem you initially set out to solve. You need to constrain what you're trying to do so that there are many different strategies to help build software and work with as a team. A lot of these have academic definitions. They help with the command structure, the work structure, the documentation and testing, as well as the implementation and deployment of code. We will be talking about them in future sessions and going in depth into several different models. For now, all you need to know is that these models do exist and we will be covering them in the future. You may research on your own if you would like. Talking about models of software development. Version control is a tool which is used to help facilitate the entire process of software development. It helps to track the progression of a project, track changes to source code, and track team members and the work that they're doing. Businesses usually store this on a central server, and this tool helps manage conflicts between different versions of the software made by different people or even the same developer over a period of time. Why is version control important? It helps to track changes if there's a bug, so that you know where the bug was introduced. You can do more dangerous edits to code with the security of knowing that there is a history that you can always go back to. It helps working with a team in making it faster and more efficient, and it helps keep a backup of every single version of the software, so that you can see the history of the software and always go back to a previous version if something goes wrong. There are two types of version control: centralized and decentralized, or distributed. The centralized version is where there is a server which stores and controls all the code, and all developers pull from that every time they work, sort of a server-client model. And a distributed source control is where people each have a local copy of their code, and then they push it to a remote location. But they have a local copy that branches off from the main version of the code. We'll only be focusing on Git, which is a distributed form of version control. A good resource is github.com, who offers a free Git service. Try.github.io is already a resource I've mentioned, and so is Node School, which also has tutorials on how to use Git. GitHub provides a free student service where they have what they call a backpack of lots of different software tools that you can get for free as a student when you register with your student email on GitHub and then go to education.github.com. There are a lot of tools that can be used with Git, a lot of graphic user interfaces for Windows and Linux, as well as command line tools. Git extensions and GitHub for Windows are two very good user interface tools if you don't want to type in commands. The terminology of Git is very similar to that of a tree. It's a good analogy. A repository is the stored history of all the source control and source code, the work in general. The origin is the main repository on the remote server somewhere else other than the developer's computer. A commit is a packet of work or a state of the repository at a given point in time. It has a message associated with it to help identify it, as well as an identifying string. A branch is a series of commits within a larger period of time, sort of a branch of a tree. The master is the main branch, sort of the thickest branch, the trunk of a tree. In the image and slide, you can see it is the very thick branch, and then there are thinner branches that branch out of that. The working copy is the assets that you are currently working with on your local machine. What tends to happen with Git branches that doesn't happen with a tree is that branches can merge back into the master branch or into any branch. You can merge them and diverge them as you see fit. Another tool that is very similar to version control that is used in software development is continuous integration. This is essentially the next step in software development. So it works alongside source control, and what it does is it runs automated tests when code is pushed to the remote repository that makes sure that the developer hasn't broken internal functions of the system. There's also the possibility for the continuous integration to do automatic deployments to some kind of live system or download center or something of the sort when all the tests pass on a specific branch, such as the master branch. Why would you want to use a continuous integration system? It makes sure that recent code changes are working. If there's already a released version of the software, you don't want to break the next version. So you don't want to lose customer satisfaction and belief in your product. It allows teams to see where low-level errors and problems may exist in the system. And it's based on test-driven software development strategies, which have the belief that tests are incredibly important in making sure that you build robust and very stable and safe software. Some examples of continuous integration systems is Travis CI and Avoyam. So I have Travis CI open in my web browser. You can see a project I'm working on that a whole bunch of tests from several different versions of Node run, and if you drill down into the test, just wait a moment for it to load, you can see that many different tests have run. It's gone through all these different tests. If I scroll down, you can see that there are 75 tests and that they're all passing. And then I have set up what's called a code coverage report, which shows what functions in my program have been covered by tests and which functions have not been covered by tests. Here you can see there's one file that has not been fully covered by tests, only 30% of the file has been, and then on this side it shows what lines of code need to still have tests written for them. This is just one kind of workflow for continuous integration and source control. The most common one that I have come across is one where the master branch is the automated deployment using source control and continuous integration. This is the release branch. Then you have a develop branch, which also gets continuous integration, but rather than it's being pushed to live, it's pushed to some kind of testing area or staging area, some kind of sub-release. These are not releases for consumers, but rather for the developers to make sure that their systems are working. And then you have sub-branches, which are branches specific to a developer or a set of developers who are working on specific feature requests or hotfixes for bugs. So talking about the sort of questions that you need to ask to constrain the problem before you start programming a software solution. A tool that's used is called use cases. Many businesses use them. It's a structured way of mapping between one or few actions and one or few objects. So that pretty much means something like a noun, a verb, and a noun. So the boy kicks a ball. So there you know that there's some object, a boy, whose action is to kick, and he enacts that action onto the object, a ball. Some examples I've given in the slides are the manager hires new employees, the doctor treats patients. They're very simple ways of breaking up a complex software solution into very small actions and objects that you can then implement. It's very important to constrain, especially a very large system, into very small sub feature requests and functional requirements. This helps in implementation so that you have essentially a checklist of smaller operations you need to get working in order to get a big system working. So rather than trying to tackle a large system, you're trying to tackle smaller issues. User stories is another way of discussing the requirements for a system. They're very similar to use cases, but they're in a story form. They also make use of user personas, or essentially fake people that you've invented, who are the potential people that will use your system. An example will be shown later. So another problem that comes up with software development and working in teams on especially large systems is you now have all these functional requirements, all these user stories and use cases, but you need a way of tracking what work has been completed, what work is currently being done, what work is in the backlog to be done, and what work, where all these bits of work are in the system and in time, and with many different developers within a team. One method of tracking all of this is called issue or ticket tracking. GitHub has a built-in system called Issues, which allows you to do this. There's another website called waffle.io, which uses the GitHub issues to make it more like the tickets that are used in a restaurant, to give a chef a table's orders that he then gives to the chefs that work under him in order to create the plate of food or the several plates of food. It's very much the same in software development, where you take the use cases or the user stories, you break them up into small statements, and then you make tickets or issues for those user requirements. If I have Waffle open in my web browser, as you can see, for the same project that I showed for Travis CI, there's a lot of work in the backlog, a lot of stuff that's ready to be done, things that are currently being done by developers, and a lot of tickets and issues that have been completed. If you go to the GitHub repository for this project, And in there you go to the issues. You can see the same issues that are shown in Waffle here in a different format over here. These are the same issues, but it's very hard to tell what's currently in progress and what has been completed. Whereas here, you have a much more in-depth overview of where the development of the system is at. We will now be covering an example using Node.js of a small software problem. What we'll be covering is the simple game of tic-tac-toe. We will not be fully implementing it, but using it as an example throughout all the sessions about the concepts we are talking about. An example user story for tic-tac-toe is this. Dave loves the game tic-tac-toe. Unfortunately, Dave has no one to play the game with. He would like to be able to play the game on his computer. He wants to be able to see a game board and input a move that he wants to make when it is his turn. He also wants the computer to start the game every time. If we break that down into use cases, you can see that it becomes this list of use cases. The computer starts a new game, the computer makes the first move, the user can make moves, the player wins when 3 squares in a row are captured, and the winner is declared. For this session, we will only cover the first 3 use cases. Running the first example. Here is the first example of the code. As you can see, it's fairly simple. I've broken up the program into several small functions that are then executed at the bottom of the program. Node.js is interpretive, so it reads whatever's in the file and then executes whatever statements are at the bottom of the file. The first example will only cover initializing a new game world and then displaying a blank world to the console. In order to run the game, all you have to do is go to the folder where the code is located, as I've done, and then run node index.js. If node is located in a global path, this should work. If it isn't, you will get an error. When I run the program, you can see it writes it to screen. The second example is slightly more complicated, and it shows the power of Node.js and the way it uses modules or code libraries. So in order to install a code library, you have to use the Node package manager. In this case, you don't use the -g command, but rather you go npm install and whatever module or repository you require, and then you have --save in order to save it into the repository. Before you can do that, however, you have to initialize the code repository using npm init. When you run npm init, as I will do in a blank folder now, I create a folder, I go into the folder, and then I run npm init. What it will ask me for when it executes, sorry, it's going to take a little bit of time. Once the npm init command runs, it asks you several different options. So it asks you to enter a name. It usually gives you the name of the folder, but you can change that. For now, we'll be using the name of the folder. It doesn't really matter. It asks you what version number you want to start with. We will start with 0.0.1. Asks you the description of your project. The entry point is the main JavaScript file that Node will run. In this case, it'll be index.js. There's nothing in the folder, so it doesn't matter. The test command, we'll leave it blank for now, but this is where you tell npm what kind of tests you want to run and what is the command to initialize those tests. The Git repository, again, we'll leave it blank, but this would be the Git repository where the remote Git repository where your code is located. Keywords, these are keywords to help search on the Node Package Manager's repository website, npmjs.com. Author, who is the author of this repository of code, or this package, and the license we would like to use, and then it asks you to confirm that this is okay, type yes, and what it has done is it has created this file called package.json. If you go to the folder we created and you click on package.json, you can see that it has created a JSON object, which is a data object of the information you filled in. This is important because this file also tracks the packages that you install into your software. So if I go back to the slides, you can see that my example has npm install readline-sync-save. We'll run that now. And you'll see that the package manager will go download and install the package. You can see it running now. Okay, so the Node package manager has finished installing the library. If we look at the directory, you can see that it has created this other directory called node_modules. This is where other modules that aren't part of your program are going to be stored in that folder. If we go back to our code editor, you can see that it has added this object into the package.json file, and this is where it saves whatever program or package you install from Node Package Manager. And it also has the version number. That little hat implies that when you run npm install without any package, that it will try and find the latest version of the software. Preferably you want to remove that so that you don't accidentally update this package to a version that is incompatible with what you're doing in your software, which then causes your software to break. Another key that can be used is this one, which tends to lock it at a major version number, but allows subversions like the end.4 to increase. Again, it is not necessarily a recommended way of using Node Package Manager, just in case someone releases an update for this software that then breaks whatever you're doing with it. So like the way the software works, if they fundamentally change that, you don't want to update that unless you're prepared to change your software in order to match that. If you look, it has created a folder called Node Modules, and in that folder there's readline-sync. If you look in there, you can see all their images, resources, README files, and code is located in their own specific folder. This allows you to reference their code if you need to. You usually don't need to look in this folder. Okay, if you go back to the second version of tic-tac-toe, which is a far larger program, you can see we are using readline-sync. In Node.js, you make it everything is a variable, and you make this variable require the library readline-sync. I've already installed readline-sync into the second example, and you can see there is the Node modules folder, and there's a package.json which relates to tic-tac-toe version 2. This version has a lot more functions. This is a very, very bad way of software development. However, it is a very good example on what not to do. We'll be covering in future sessions on proper ways of breaking up your code to make it more manageable. There are 2 bugs in this code, but they're very, very hard to find, such as where it doesn't actually detect that the user has inputted the correct world. The way user input is handled is using this library called readline-sync. This is us using that variable we created at the top, asking a question of the user, and then storing that in a variable called user_in, which we have instantiated here. Node.js uses implicit variable typing, so you just use the declarative call called var, rather than saying int or double or float or boolean or bool. You just use var, and then you assign it a variable such as null or false or a string input of some kind, or any number. If you use numbers, you will have to use parseInt and parseDouble in order to make sure that Node knows that it is a number and not a string, else you're going to get weird things happening. On using a library with Node.js, it helps that using other people's code that you then don't have to implement this functionality yourself. As you can see, I've got a commented out alternative way of getting console input. It's a lot more, and it's a lot more complex than just using this library, which is one line to ask the question and then another line to break up the user's input into an array of strings that you can then use later on in the software. If we run this program the same way as the program before, node index, sorry, wrong folder. If you go to the folder with the second version of tic-tac-toe, we want to run it, you go node index.js, you run it, you can see it initializes the world and prints the world just like tic-tac-toe 1, and then the computer does a random move on the board, and then it asks you to input a move that has not yet been done. We'll input the move 2, 2, and as you can see, the user is O, the computer is X, and the user's move has been registered. And the computer has now done another random move, which is 1, 3. We'll do another move, which will be 2, 1, and as you can see, something has gone wrong. It has now overwritten a move that the computer has made. The unfortunate thing is, it is very hard to find what that bug is in this code in the way I have programmed it, as these small functions. This is better than just having one main function with all the code located in it, which is just one long stream of code. However, there are still issues breaking it up like this. It's not clear how the code flows into itself. We know that the initial point is main, and then main is called at the bottom of the file, but we don't know from here where all these different functions come in, what calls what, how things are involved with each other. So it becomes very difficult to find the issue where it is not detecting the correct move of the user. I programmed this so I know that after the main function, the most important function is the askMove function, which is the function that asks the user for the move they want to make. A new user coming into this code would have a very hard time of trying to figure out my logic and where everything is and how everything functions together. For homework, run through the program and try and find where the issue is. You don't necessarily have to find it, but you need to be able to see that it's quite difficult to run into someone else's code, especially code that has not been properly developed using conventions and standards of software development. This is the end of the introduction session to software development. This final slide, there's some free stuff for students. If you have a student email, you can go to theeducation.github.com, sign up for GitHub using that email, and then get their free software and tools for students. There's another company called jetbrains.com. They also have a student discount. They provide tools for software development in continuous integration, in source control, in software code editors, integrated development environments, and a whole bunch of other code suites for many different languages. As you can see, this is what WebStorm is a tool you can use with this course. It's a lot more comprehensive than Sublime Text. Again, they also require you to at least have your student email registered to your account so that they can verify that you're a student. You can find me at jasonchallam.com, and you can contact me at contact@jasonchallam.com. Thank you very much for watching, and have a nice day.